So in this video, we want to talk about how to sketch the reciprocal of a function that we already have the graph of. But before we get started, let's talk about some basic math knowledge that we should recall. So first of all, remember you can never divide by 0. So if in my original function, I see that the y value is 0, this means in the reciprocal function, it will not exist because you can't divide by 0 in the real number system. We should remember that 1 divided by a very large value is very close to 0. Like 1 divided by 1,000,000, for all intents and purposes, is 0. Whereas the reverse, if I have 1 divided by a very small decimal, that will be infinity. And then it's important to remember that if I divide by a positive number, it doesn't change the sign. So because it's 1 divided by a negative number will still be negative. 1 divided by a positive number will still be positive. So in general, when I try to graph this reciprocal transformation, I will basically follow these steps. So I want to identify any zeros of the original function. I want to look at the end behavior on the far left, and then in the very end on the far right. And I want to consider the behavior around any asymptotes. So for a second, let's switch over to Desmos. I already have a graph here. So the red function is my original f of x. Here's the graph. Notice right here at -1 and 1, I have zeros. The y coordinate is 0, which means in the reciprocal, those are going to turn out to be my asymptotes. And as I get ready to sketch this, I want to focus on what happens. So as x approaches -infinity, like along here, as x approaches -infinity, what happens to this red function? The y coordinates get very large, they approach positive infinity. So then 1 over f is going to approach 0. Because as I divide by larger and larger values, it's getting close to 0. But be aware, it keeps the same sign. So in the end, it's going to still be a positive y value. We're going to be above that x-axis. We'll do a couple examples. The next thing I want to consider is like what's happening around here. I want to focus on, okay, as I approach this asymptote from the right, what happens to the red function? What's that going to tell me about the reciprocal function? So let's go ahead and show the reciprocal transformation on the graph. So as I get to these very high values of f, it's becoming 0 in the reciprocal. The same is true as x approaches positive infinity. This red graph goes off to positive infinity, which means the blue graph, the reciprocal, is going to get close to 0. But I also want to see what happens around this asymptote. So looking at the red function, the red one, as I get close to this asymptote from the left, is getting close to 0, which means the blue one is approaching infinity. But of course, the red function, as we approach on the left, is positive, which means that the blue reciprocal will still also be positive. And we can also note that a local minimum of our original function, the red function, will become a local maximum of our blue function. So let's try a couple examples. Let's come back here and scroll down. So example number 1, let's give ourselves some space. First, let's make notes of the zeros. I can see that there's a 0 at 0, 0 and at 3, 0. So my reciprocal function is going to have an asymptote here and also here. Great. I have my asymptotes, and those are asymptotes because f of x equals 0 when x is equal to 0 or 3. So this means 1 over f of x has asymptotes at x equals 0 and x equals 3. Next, I want to consider like what's happening to the behavior. So first, let's go ahead and focus on the very end behavior way out here. So as x approaches -infinity, as I move further and further to the left, this graph is approaching positive infinity. Like the y values that are coming out, the y coordinates are larger and larger. So 1 over f is going to approach 0, but notice this is all positive. This is all positive. So it's going to be above the x-axis. So we're going to have some sort of approach here. That is not a very good curve. It's approaching 0. That's all I have from this information. Next, let's focus on what happens as we get close to this asymptote coming from the left. So as x approaches 0, but from the left-hand side, my graph is positive and it's getting close to 0, which means the reciprocal function is getting close to infinity, and these are all positive. So this is going up towards infinity. Next, we look at what happens on the other side of my asymptote. So x approaches 0, but now from the positive side, like going backwards, like this way. My f function is negative, but it's getting close to 0. So 1 over f is going to approach infinity, but it's negative. I'm on the negative side. So it's going to approach negative infinity. These are all negative. By all, I mean like both f and 1 over f. Coming along here, I guess I should sketch that actually. So what's going to happen? Before I can get the middle part here, I have to consider that value, the value of the actual minimum here. So here I have a minimum value where x is 1.5 and y is -2. So in the reciprocal function, so f of 1.5 equals -2, which means 1 over f of 1.5 is -1/2. So here I have my local maximum in the reciprocal transformation. So I can bring that curve a little bit further over. So as I move from left to right on the graph, I'm just considering what happens at the end behavior, what happens around the asymptotes. I should also take a look at the min or max, but that's sort of going to come from noticing the behavior around the asymptotes. So moving further to the right, what happens here? So my actual function, f, so as x approaches 3 from the left, what's happening to my graph? The graph I'm looking at approaches 0, but it's doing so from the negative side. Like these are negative, which means 1 over f is approaching negative infinity. So it's coming back down here. I still have 2 other pieces to consider. What happens right after the asymptotes? So as x approaches 3, but from the right. So we're talking about like what are we looking at when we come down this curve towards the asymptotes? Well, f is approaching 0, but it is positive. So 1 over f is going to approach infinity because it's still positive. We don't change signs just because we divide 1 by a number. And then very lastly, what happens out here at this very end behavior? I've run out of colors, so we're back at blue. So as x approaches infinity, so for very, very large x's, f is also approaching infinity, which means 1 over f is approaching 0. And these are all positive. They're going to stay on the same side of the x-axis. I forgot to add the purple part to my graph. So this is approaching positive infinity there. And then the end of my graph is coming back towards 0. Here is how I approach the graph of the reciprocal. Of course, when you draw it, you're not going to have all these highlights on it. And in the next one, maybe I'll leave it out. So let's go to the next example, example 2. This one has more going on. it has 3 places where it crosses 0. So there's going to be more to consider. First of all, f of x equals 0 when x is, I assume this label is for the -2, even though it's a little bit off to the side. So -2, 1, and 5. So in my graph, I'm going to have asymptotes here at -2, 1, and 5. All right. Now that I have the asymptotes, I know where I need to consider the behavior. Maybe I'm going to draw the local max and the local min and the reciprocal just to make it easier to put my pieces together. So if here I have -1, 1, in the reciprocal, I'm going to have -1, 1, because 1 divided by 1 is still 1. Over here, in the original function, I have 3, -2, which means in the reciprocal, I'm going to have 3, -1/2. There's no scale on the y-axis, so I don't really know where to put that point, but like closer. It's closer to the axis than -2. It's like 3/4 of the way up. Now let's consider the end behavior. So what happens to my graph way out at this left-hand end? So as x approaches -infinity, this graph I'm looking at on the screen also approaches -infinity, which means the reciprocal function is going to approach 0, but it's going to do so from below. It stays negative. So way out here, I got like this situation. So now what happens? Close to this asymptote, but a little bit on the left-hand side. So next, what happens as x approaches -2 from the left? The function I'm looking at on the screen, as I come up here and I get close to the asymptotes, f is approaching 0. So 1 over f is going to approach infinity, but because my values are negative, it will be approaching -infinity. So we got this part of our graph. Now on the other side of the asymptote, what about here? As x approaches -2, but from the right-hand side, again, I know the graph is getting close to 0, but it's positive, which means the reciprocal is going to approach positive infinity. And I know where to draw the minimum there because we already calculated it. I can see the opposite is happening here as I approach this next one. So as x approaches 1 from the left-hand side, the function is approaching 0. It is positive. So the reciprocal is approaching positive infinity. On the other side, now I'm in the negative values of f, and I'm on the right-hand side of this asymptotes. So as x approaches this asymptote, but from the right-hand side, my function, so like coming up this way, is approaching 0, but it's negative. So my reciprocal is going to approach -infinity. It's coming down here. Again, I already found the local max, so I know that it run it through that dots. Now I'm going to look at the next asymptote. What happens as x gets close to this asymptote from the left? So x approaches 5 from the left-hand side. My function is getting close to 0, but it is negative, which means 1 over f is going to approach -infinity. No surprises there. I still have 2 more places to consider. What happens on the other side of this asymptotes? So on the right-hand side, so what happens as x approaches 5, but from the right-hand side, so coming down like this, f is approaching 0. It is positive. So 1 over f is approaching positive infinity. So as I go towards my asymptote, it is getting close to infinity. And lastly, we consider our other end behavior. So as x approaches infinity, this graph I'm looking at also approaches infinity. It's positive. So the reciprocal will also be positive. And 1 over f is going to approach 0. So we're getting close to here. That's it. It's a lot of considerations. Like when you have this long list, it does seem like a lot, but we want to consider the end behavior and the behavior around the asymptotes. And the asymptotes come from the zeros of the original graph. Let's do one last example. So here's the graph I'm already starting with in the first place. This one's a little more complicated. There's a little bit more going on. I have a local maximum. I have some asymptotes. I have also a horizontal asymptote. Let's consider the zeros. So I can see right here, this graph crosses 0. So f of 2 equals 0. I'm going to make this a little bit thicker so we can see it better, which means I will have an asymptote here. If we allow ourselves to consider the entire real number system, so we don't restrict and say that this asymptote is not part of the domain, then that will become our new 0. It's the exact opposite of what we just had a second ago. So the 0 in the original f function becomes an asymptote in the reciprocal. And an asymptote in the original f function is going to be because it had divided by 0, which means in the reciprocal, it will become 0. This is a little bit willy-nilly, in my opinion, because of the definitions here. In theory, these values don't exist at all. I would argue that they should be wholes. But typically, it's not going to be that specific. We're just going to leave them in. So we're going to say, like, in the limits, it gets pretty close to this point here. Okay, so I have my vertical asymptotes. I have the zeros. I may want to already consider what happens to this horizontal asymptote. So right now the asymptote is at 1. But 1 divided by 1, fun times, that's still 1. So in the reciprocal, I will also still have this asymptote. So this is x equals 2, and this is y equals 1. All right, let's consider some end behaviors. So here, at the very left of my screen, as x approaches negative infinity, the graph I'm looking at approaches 1. So 1 over f is going to approach also 1, because 1 over 1 is 1. We should pay attention to whether these values are positive or negative. So these are all going to stay positive. You can't see my screen. Because the f value is positive, like the y coordinate of f, the reciprocal is also going to be positive. So we're going to be coming like here. In fact, I could draw that better because I know that the 0 is this guy. Okay, let's go ahead and put the reciprocal of this local max. So right now we have a local max at 0, -2. So in the reciprocal function, we'll have a local min at 0, -1/2. What happens to my graph just on the right-hand side? Oh, sorry, the graph. Just on the right-hand side of this 0 function, it's currently an asymptote. So as x approaches -1 from the right-hand side, f is approaching negative infinity. So 1 over f is approaching 0, and these are all negative. So that's where we get this little guy from. On the other side, so considering like this part of the original graph, as x approaches -1, sorry, as x approaches +1, but from the left-hand side, my f is approaching -infinity. So it's negative, which means 1 over f will also be negative. 1 over f is going to approach 0. So we're coming back to 0. What happens here on there's so much going on. On the right-hand side of the asymptote of the original function, I'm trying to figure out what do I do with this graph, the reciprocal in this region. As x approaches 1, but from the right-hand side, so coming down this way, f is approaching -infinity. So 1 over f is approaching 0, and they're all negative. This, I've lost part of my asymptote here. That looks ridiculous. But here we are. So it's supposed to be approaching 0. Okay. I try not to draw too much of that because I already have a new asymptote to consider, like very close by. So what happens as our original function approaches its 0, which is the asymptote in the new one? We have, erase this. So as x approaches 2 from the left-hand side, f is approaching 0, but it is a negative value. So 1 over f is approaching -infinity. Coming down like this. Maybe I want to smooth this out. So we got this coming up here. We still have a little bit to consider, but soon we'll be done because we still don't know what's happening with this part of the graph, which is just to the right-hand side of my 0 in the original function and also the very end behavior. So let's look at this guy. What is happening as I travel to the left on my graph? What happens as x approaches 2, but from the right-hand side? F is approaching 0, however, f is positive. So 1 over f is approaching infinity, positive infinity. So coming up like this. There's a severe lag on my screen drawing. There we go. Very last thing to consider, what happens as x approaches infinity. So x approaches positive infinity. This graph, oh no, I've drawn my line too long. The graph of f, like as this goes further and further this way, f is approaching 1. So 1 over f is also approaching 1. And these are all on the positive side as well. So I got to go back, shave off a little bit. I drew too far. So the end behavior means this is approaching this asymptote right here. I'm going to trace over it a little bit thicker. So my reciprocal function, it comes over like this. I come down, it hits a local min. Here I have a little max. I come down again. Here we're looking like this.